doing my PhD in oil and gas industry, Institute of Petroleum Engineering, and I'm basically a chemist, so working on the chemistry part, but I'm not going to tell you the chemistry part of it. I just give you the overview of how oil industry deals with it and what are the problems regarding it, and I'll drag you up to the point where my research starts. I'm not going deep into my research, okay? So this is the outline of the presentation. You might have so many questions after that. Don't ask here, we don't have time. Just jump in. So the main problem in the oil industry is the scale. What do you think, what is scale? In your day-to-day life, you might be dealing with it at some point.
You weigh yourself.
Sorry?
Something you weigh yourself.
I don't think so.
You're asking this from movement.
Okay.
Yeah. Scale.
Scales is like something on top of, kind of like
Sorry?
the when you have rust or something that
You're getting it. You're getting it. You're very close. Rust is another problem in the oil
I know,
industry.
but I can't define it. It's
Yeah.
a scale on.
Actually, in your day-to-day life, you're using kettle, right? Kettle. And sometimes you will get white salts in your kettle.
Korean something.
Yes, corrosion is another problem. But this is like a white salt which comes from hard water, right? Incompatibility of hard water with different parameters. So you will find scales. And scale, you will find descalers in Asda and in other supermarkets for your kettle. But in oil industry, where the huge and the very big problem is scale, you won't get rid of very easily from like descalers. So, what are the problems caused? We will look at it, and common oil field scales, mechanism. I mean, we are not going deep into that, but let's start. Let us start. So scale is a hard crystalline deposit resulting from the precipitation of mineral compounds present in water, and it could be the result of different parameters which are like high temperature, pH. I mean, maybe you're not familiar with these parameters, but that cause scale problems. And it is typically a compound material, so it is made up of one or two or more organic materials, and it is mostly insoluble, and it may cause corrosion as well, the one you were saying, rusting. That's another thing. So this is the I mean, the bigger picture I will show you, but this is the most microscopic picture, and that's how it looks. It has some pointy, this is the pointer? Yeah. It has some pointy scales. Some are very insoluble, some you can dissolve depending upon the nature of the scales. So, this is the this is the pipeline where you will get oil out, and that's how it corrodes, and then it forms scales, and it blocks all the pores, and it blocks everything out. So it's a huge problem in the oil industry, and when it clears out, you can see this is how it looks like. And this is again after this is the separator. This is a separator. So after scaling, you can see this seems like a hard bit material, isn't it? And after clearing up, this is the amount you can pass through the oil. So to get rid of these problems, management trying to put either like fluid modification, flow modification, everything involves in the management options. You can control the damage, you can predict the damage by some software related skills, and you can inhibit the damage as well, or simply set aside, do nothing, and bear the cost. That would be one of the easiest options, but our industry always go for oil. So these are the common scale inhibitors which we are working on, phosphonates and the polymers. and this is the basic structure, chemical structure of those compounds. Phosphonates is single compound, but polymers are more chain-like structures. So I'm working on polymer scale inhibitors, and here my PhD starts. So I'll drag you up to a point where my PhD starts. So thank you very much for listening with patience.
Thank you very